Bismillahirrahmanirrahim. Peace and blessings. According to the Newton's second law of motion, the force applied on a body is equal to the rate of change of momentum. That is, force is equal to change in momentum divided by time. First, let us know what is momentum. Well, in simple words, momentum is the product of mass and velocity. In other words, momentum of a body makes us guess how easy or difficult it is to stop a moving body. Mathematically, momentum equals mass times velocity, which clearly shows that momentum depends on mass and velocity both. Momentum is a vector quantity and its direction is same as that of velocity. Since unit of the mass is kilogram and unit of the velocity is meter per second, hence unit of the momentum is kg meter per second. Now let's try to understand momentum with the help of an example. A bullet moving with velocity of 400 meter per second. It will have a very small momentum as compared to the momentum of train with a very small velocity of about 22 meter per second. It is because although the speed of the train is way too slow, but its mass is very huge as compared to the mass of 10-gram bullet. The only advantage of the bullet is its sharp edge, which makes it penetrate through an object easily. But even then, momentum of a train is very huge as compared with bullet. Now let's come back to the topic. Sir Isaac Newton during his experiments found that force is directly proportional to the change in momentum. Or we can say that force is proportional to the final momentum minus initial momentum. Suppose we call it statement number 1. And a common practice is that larger the time interval for which the force is applied, the smaller will be the impact of force. So we can say that force applied on an object is inversely proportional to the time interval. Let us suppose this is our statement 2. Comparing statement 1 and 2 gives us F is proportional to the Pf minus Pi over delta t. But Pf is equal to final momentum, which is equal to mass multiplied by final velocity, and Pi is initial momentum, which is equal to mass multiplied by initial velocity. So force is directly proportional to the final momentum minus initial momentum divided by time. Now if we take m as common, we can write that mass multiplied by Vf minus Vi divided by time interval. Interestingly, Vf minus Vi over time interval is equal to acceleration. So above statement can be written as F is proportional to mass multiplied by acceleration. Or removing the proportionality sign gives us F is equal to K multiplied by mass times acceleration, where K is constant of proportionality and K is equal to 1. So we get F is equal to ma, where this final relation shows that force is directly proportional to the acceleration, which is actually another statement of second law of motion. I hope friends you have understood the relation between second law of motion and momentum. Friends, if you found this video helpful, let us know in comment section. And don't forget to subscribe to our channel. We need your support and love. Take care.